See the case of association. In case of association, number of solid particles decreases, molar mass increases, and therefore the value of colligative property decreases. And in case of association, the value of Wantor factor is always less than 1. See some examples. Here are the 4 atoms of phosphorus. It associates to form a P4 molecule. 8 sulfur atoms combine to form S8 molecule of sulfur. 2 molecules of acetic acid, they undergo association and form a dimer. See the example. See in the diagram, there is formation of dimer by intermolecular hydrogen bonding. Similarly, 2 molecules of benzoic acid, they dimerizes to form a dimer. They associate to form a dimer. So here the molar mass increases and the number of solid particles decreases, and that's why the value of Wantor factor is always less than 1. See the calculation of Wantor factor. Let we have n number of B particles and it undergoes association to form Bn molecule. Initially we have taken A moles of P particle and let alpha be the degree of association. So it is equal to A minus A alpha, and the number of moles of product, this is equal to A alpha upon N. Now calculate the Wantor factor value. This is number of particles after association upon number of particles before association. So this is equal to 1 minus alpha plus alpha upon N. Or it may also be written as I is equal to 1 minus alpha into 1 minus 1 upon N. Here number of particles, N is the number of particles which undergo association. Calculation of alpha, that is degree of association. So I is equal to 1 minus alpha into 1 minus 1 upon N. Or it may be written as alpha into 1 minus 1 upon N. This is equal to 1 minus I. Or alpha is equal to 1 minus I upon 1 minus 1 upon N. Say one example. For example, benzoic acid dimerizes up to 90%. Calculate Wantor factor. So we have the expression I is equal to 1 minus alpha into 1 minus 1 upon N. So here the value of alpha is 0.9, that is 90%. And the value of N is 2. It means there are 2 molecules of benzoic acid, they undergo dimerization. So the value of I, this is equal to 0.55. Similarly, if we have the value of I for dimerization of acetic acid, 0.6, then we can calculate the value of alpha, that is degree of association. So alpha is equal to 1 minus I upon 1 minus 1 upon N. So put the value of Wantor factor 0.6 and value of N as 2. So it comes out to be 80%. So in this way we can calculate the Wantor factor and degree of association. Now say, if we have same molar solutions, then in such type of solutions, delta TF, that is depression in freezing point, is directly proportional to I, that is the value of depression in freezing point increases with increase in Wantor factor value. Similarly, delta TB, that is elevation in boiling point, is also directly proportional to I. So the value of delta TB increases with increase in the value of I, that is Wantor factor. So TF, that is the freezing point of solution, it is inversely proportional to I. TB, that is boiling point of solution, it is directly proportional to I. Relative lowering vapor pressure, it is directly proportional to I. PS, vapor pressure of solution, it is inversely proportional to I. And the Wantor factor pi, this is directly proportional to I. So these will help you in solving some numericals. Sometimes the same molar solutions, different solutions having same molarity are given, and you have to calculate these Wantor factor, that is colligative properties. So this will help you in solving the problem. Now for electrolytic solutions, the modified colligative properties or colligative properties for electrolytic solutions, where the Wantor factor may be greater than 1 or less than 1. So see the expression, relative lowering in vapor pressure, P naught A minus PS upon P naught A, this is equal to I into XB, that is mole fraction of solute. We know that since we know that I is equal to colligative properties observed upon colligative properties normal, that is colligative properties after association or dissociation upon colligative properties before association or dissociation. Similarly, delta TV, that is elevation in boiling point, this is equal to I, that is want of factor into Kb into molality. Delta TF, depression in freezing point, this is want of factor into Kf into molality, and pi, this is want of factor into CRT. So these are the modified colligative properties. So if we have such type of solutions in which the solute is electrolytic in nature, so we will apply these formulas for the calculation of colligative properties. See one example. We have 1 molar urea solution, 1 molar NaCl solution, 1 molar magnesium chloride solution, and 1 molar potassium ferrocyanide solution. So for the same molar solutions, we know that delta Tb is directly proportional to I, delta Tf is also directly proportional to I, Tb is directly proportional to I, Tf is inversely proportional to I, relative lowering vapor pressure is directly proportional to I, PS, that is vapor pressure solution, is inversely proportional to I, and the want of and osmotic pressure is directly proportional to I. So here the want of factor for urea, it is 1 because urea is non-electrolytic in nature, so the number of solid particles after dissociation, it is 1, and before dissociation is also 1, so it comes out to be 1. For NaCl, the number of solid particles after dissociation 2 and before dissociation is 1, so the value of want of factor is equal to 2. For magnesium chloride, the value of want of factor is 3, and for K3, FeCN6, the want of factor value, this is equal to 4 because number of solid particles after dissociation is 4 and before 1, so it comes out to be 4. So now we have the value of want of factors, and this is for their molarities are same, so we can apply the concept. So see the relation delta Tb, here the value of delta Tb increases with increase in the want of factor value of Tb is also increases with increase in want of factor value. Delta Tf, it is also increases with increase in want of factor value. Tf, it decreases with the increase in want of factor value because it is inversely proportional to I. Value of relative lowering vapor pressure also increases with increase in want of factor value. PS, that is the vapor pressure of solution, it decreases with increase in water factor value, and the value of osmotic pressure, it increases with increase in water factor value. So in the next class we will see some numericals. Thank you very much.